I would like to present my project for SENG 475 at the University of Victoria, which is an implementation of collision detection for 3D objects. The goal of this project is to develop a library which can determine whether a pair of convex 3D objects are intersecting. An additional goal is to develop an application to demonstrate this library. Collision detection is widely used in video games and other types of simulations. Simulations that model real-life scenarios typically don't want objects to intersect, since this does not happen in reality. Therefore, intersections between objects need to be detected algorithmically. In this project, only collisions between convex objects are considered. This assumption simplifies the implementation. Splitting concave objects into a collection of convex objects allows convex collision detection to be applied to concave objects. The library for detecting intersections uses an algorithm based on the Gilbert-Johnson-Kearthy, or GJK, distance algorithm. GJK outputs the shortest distance between two objects, whereas this library can only determine if two objects are intersecting. So this is not strictly an implementation of GJK. However, this algorithm uses similar techniques to those used in GJK. A video by Casey Muratori clearly explains the techniques that I'm using. I don't have time to explain the algorithm in detail, but I can give a brief overview. A and B are the sets of points under test for intersection. The algorithm works on a set called the Minkowski difference of A and B, which is the difference between every pair of points from A and B. If 0 is contained in this set, there is a point common to A and B, meaning they intersect. The algorithm works under the assumption that A and B are convex. This means the Minkowski difference is convex. The algorithm detects an intersection by constructing a simplex from the points on the convex hull of the Minkowski difference, which contains the origin. If there is no intersection, the algorithm shows that there is no such simplex. For 2D collision detection, this means finding a triangle enclosing the origin. For 3D, a tetrahedron. This library is implemented in the file gjk.hpp. The public interface consists of one function called intersectgjk. This function takes a template parameter for a three-dimensional vector type. This allows interval or arbitrary precision real types to be used if robustness is desired. The function has two required parameters, which are support functions for each of the objects under test. A support function takes a direction and returns the furthest point along that direction, thus fully characterizing a convex object. The two optional parameters are a limit to the number of iterations taken by the algorithm, and a pointer to a structure where statistics of the invocation of the algorithm are returned. The limit on the number of iterations is needed because the algorithm is not guaranteed to terminate for floating point types or continuously curved surfaces. The demo application demonstrates this library. It is a graphical 3D application which lets the user create and position objects in 3D space. The application indicates when objects are intersecting by changing their color. The shape of each object is defined by a mesh. Each mesh is loaded from an OFF file. The vertices of each mesh define its convex hull, and therefore how it intersects with other objects. The faces of each mesh are only used for rendering. Now I will demonstrate this application. The demo script launches the demo application and loads 5 meshes. A window should have opened, which appears black. This is because no objects have been created yet. To create an object, press the up arrow. It can be translated and rotated with the controls given in the README. Another object can be created by pressing the up arrow again. This object is blue to indicate that it is selected, which means that the keyboard controls apply to it. The selected object can be changed with the left and right arrow keys. Any number of objects can be created. The selected object can be deleted by pressing the down arrow. Holding Shift and pressing the rotation keys allows the entire scene to be rotated. Objects can be moved to intersect with each other. The intersections are detected and indicated by changing the color of the intersecting objects. While intersecting, the selected object appears magenta and deselected objects appear red. The demo application has a text interface in the terminal where it was started. The currently loaded meshes can be displayed with the list mesh command. The mesh of the selected object can be set with the mesh command. The mesh of the selected object can also be set by holding Shift and pressing the left and right arrow keys. The quit command will exit the demo application.